So number 2 here is a little bit easier. In fact, they want you to do this one without actually using a calculator. And it says the hydronium ion concentration of a solution of sodium sulfate is 3.61 times 10 to the negative 8th molar. State whether the solution is acidic or basic without calculating the pH. And the solution here says the hydronium ion concentration is between 10 to the negative 7th and 10 to the negative 8th. That's this number right here. And it is closer to 10 to the negative 8th than it is to 10 to the negative 7th. Its pH must be between 7 and 8 and is probably closer to 8. The solution is therefore basic. So basically what you're going to do is look at that exponent, and if it's above 7, it's probably basic. If it's below 7, it's probably acidic. Alright, so the next problem is number 3, and it says a typical cola soft drinks have pH values of 2.8 to 3.4. What is the range of the hydronium ion concentration for soda? So 2.8 to 3.4. Oh, here's the question again. There we go. So we have a pH of 2.8. So remember, you can calculate the hydronium or hydrogen ion concentration by plugging in the pH as a negative exponent. So if I do 10 to the negative 2.8 on my calculator, I get, that's a 0.8, not a 28. So 10, I'm just going to do it simple on my calculator. 10, use my little caret, negative 2.8, and I got 1.6 times 10 to the negative third. And then the other end of the range, the high end of the range, is 3.4. That's a 4. 10 caret negative 3.4. And I got really 4.0 times 10 to the negative fourth. So your answer, the range, right? The range of the concentration for soft drinks would be between 1.6 times 10 to the negative third and 4.0 times 10 to the negative fourth. And considering that's the higher exponent, but it's negative, I probably should have put them in the opposite direction. But anyway, that's how you do that one. Next question, assume that the pH of household bleach is 12. What is the hydronium ion concentration in household bleach, and what is the hydroxide ion concentration? So the official solution is here. We know from our lesson that the hydronium ion concentration multiplied by the hydroxide ion concentration equals 1 times 10 to the negative 14th. The question is first asking for what is the hydronium ion concentration. That's the H3O plus. So if you rearrange this equation to solve, you can obviously get the hydronium ion concentration, and you can get the hydroxide ion concentration. So I'm going to show you how to do it this way, and then I'm going to show you the tricks of the trade. So let's get to it. Alright, let's write down what we know at least. If I take the concentration of the hydrogen ion or hydronium, you'll also see this written as hydronium. Both of them mean the same thing. Multiplied by the hydroxide ion concentration, you get 1 times 10 to the negative 14th molar. Alright, so let's see what we've got here. That we have a pH of 12, and I know from pH I can calculate the concentration of the hydrogen or hydronium ions. So let's do this just so that we stick with hydronium. I know that I can take 10 raised to the power of the negative pH, and I'll get the concentration. So 10 raised to the negative 12th is just 1, right? Times 10 to the negative 12th. So that's my answer. So that's the concentration of the hydronium ion. And if you want to just keep it simple, you can always just say that it's the concentration of the hydroxide. I'm sorry, it's the concentration of the hydrogen ion. Same thing. Okay, so the next part of the question is, what is the hydroxide ion concentration? Well, using this equation back up here again, if I know, right, if I know that the hydrogen ion concentration, this number here, is 1 times 10 to the negative 12th, and when I multiply it by the hydroxide ion concentration, I get 1 times 10 to the negative 14th, I can rearrange the equation and solve for this variable right here. So let's do that. I am going to divide both sides. All right, let me use green. I like green. I'm going to divide both sides by the hydrogen ion concentration. And if I do that, I end up with the hydroxide ion concentration is equal to 1 times 10 to the negative 14th molar divided by the hydrogen ion concentration. And if I plug in what I know, I have 1 times 10 to the negative 14th molar divided by 1 times 10 to the negative 12th molar. That's this number right here, right? And if I plug that into my calculator, I get, I'm going to kind of call out the buttons I'm pressing on my calculator. 1 exp negative 14 divided by 1 exp negative 12. And my answer, if I can fit that in here, is 0.01 molar, which is the same thing as 1 times 10 to the negative second molar. So that is the hydroxide ion concentration. And this one here, right, is the hydrogen ion concentration. So let's take a look at that. Let's make it nice and neat. The hydrogen ion concentration is 1 times 10 to the negative 12th molar, and the hydroxide ion concentration is 1 times 10 to the negative second molar. And that makes sense because if I take negative 12 and negative 2 and I add them together, I get negative 14. Alright, now I'm going to show you how I do this, tricks of the trade. If I know that the pH is equal to 12, that means that the pOH is equal to 2, because pH plus pOH equals 14. And so if I know that the pH is equal to 12, I can calculate the concentration of the hydrogen ion by raising it to a power of the negative pH, which would be 10 to the negative 12th, which equals 1 times 10 to the negative 12th molar. And I can also calculate the hydroxide ion concentration by raising, if I take 10 raised to the power of the negative pOH, I can do plug that number in, I get 10 to the negative second, and that just equals 1 times 10 to the negative 2 molar, and there are both of my answers. And so that's how I'm going to do number 5 as well. Milk of magnesia is a common antacid, and it has a pH of 10.5. What is the hydroxide ion concentration of milk of magnesia? So this is a pH of 10.5, which means it's basic, which makes sense. It's an ant acid, right? Ant means opposite. So you drink milk of magnesia to kind of neutralize some of that stomach acid in your belly. So the hydroxide ion concentration, that's what we're looking for, is equal to, I know it's equal to 10 raised to the power of the negative POH. But I don't have POH, I have pH. But what we do know is that pH plus POH equals 14. And so if pH is 10.5 and adding that to POH makes 14, all I have to do is 14 minus 10.5 and I get 3.5. So POH equals 3.5. I can take that number and plug it in right up there. I get 10 to the negative 3.5, which equals, let's do 10 and a caret and a negative 3.5 on the old calculator. It's going to equal, 3.16 times 10 to the negative fourth molar. So that is the concentration of the hydroxide ion in milk of magnesia. Now, some of you don't like scientific notation, right? So this would just be 0.0000316 molar. Same thing, right? If I move my decimal point, it goes 1, 2, 3, 4 places to the right, which if I write it in scientific notation looks like that.